Hey guys, we are going to visit our last part of our unit on functions. We're going to get this screen focused, and we're going to take care of business, understanding now that we have this data, this input-output value, this independent-dependent value, how to actually put it onto a graph and what it actually means once it is graphed. All right, so we're going to go ahead and give ourselves the title of 3-4 Graphing Functions. And then we're going to write this statement of, after finding the domain and range, we can graph the outcomes to show all possible solutions. So now I gave you two pieces of graph paper in class to use. I'm going to use 2 sheets of regular paper and 2 sheets of graph paper for these notes. So you can go ahead and model it the same way if you choose. All right, so after finding the domain and range, we can graph these possible solutions. So we're going to take a look at the first one, and we're going to just simply be graphing the domain that's already going to be given to us. All right, and so these graphs are going to be discrete graphs because we are going to be given specific points. So remember, we learned the difference between discrete and continuous. Discrete simply means points on the plot. Continuous means that there's data in between. All right, so here I am given an equation. All right, it says negative x plus 2y equals 6. And it has the domain of -4, -2, 0, and 2. So it's telling me specifically to use these specific numbers. Okay, and so we're like, all right, I can do that. All right, so in order to do this, our first step is we need this to say y equals. Because these are the x values, I want to rearrange this so that it gets me what y is. So I want to know, what is that outcome going to be in the end of this? Okay, so to do this, we are going to rearrange. So I'm curious, if I have negative x plus 2y equals 6, how will I get it so that it says y equals? Go ahead and try and rearrange it. All right, so let's see what you did. You should have added x to both sides. So we would have 2y equals x plus 6. I then would divide both sides by 2. So y equals 1/2 x plus 3. So when I divide by 2, I'm dividing both of these parts by 2. So that way 1 divided by 2 got us 1/2, and 6 divided by 2 got us 3. All right, so now that we are in a format that I'm working with, I need to take each of these values and I need to plug it into our function rule. What I typically do is I usually make myself a table. And I say x and y. And on the x side, I'm going to go ahead and I'm going to list my domains. And I'm going to say -4, -2, 0, and 2. Again, that is what's given to me. That is what I write. And so I'm going to take each of these numbers and I'm going to plug them in for x. So x is going to be coming out, and these numbers are going to be going in. So first thing is I'm going to plug in -4. -4 times 1/2, well, that would be -2. So half of -4 is -2. And adding 3 to it would make the number 1. Now, if you struggle to understand what those numbers were mentally, please make sure you're using a calculator. All right? If I plug -2 in here, half of -2 is -1, and -1 plus 3 makes 2. And go ahead and tell me, what would it be if I plugged in 0? And what would it be if I plugged in the number 2? So if I plugged in 0, 0 times anything is 0, plus 3 is 3. Half of 2 is 1, and 1 plus 3 is 4. So here I should have gotten the answers of 1, 2, 3, and 4. So if it said, well, what is your range? I could say 1, 2, 3, and 4. But again, the heading says graphing function. So I need to graph this domain and range. So each of these values in my table is the points that I'm going to be graphing. So I'm going to just do a quick graph. So I'm going to draw a plus sign because I have some positives and some negatives. I'm going to go ahead and I'm going to give myself 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It doesn't have to be perfect. And I'm going to go ahead and plot these points. So it wants -4, 1, so 1, 2, 3, 4, up 1. -2, 2, 1, 2, 1, 2. 0, 3, and 2, 4. Now, naturally, we have the tendency to connect these dots, but remember, I was given 4 specific spots, which means these 4 specific spots stay exactly as is. Okay? All right, so we're going to have you try this on your own. I'm going to make this, get to this, and I'm going to actually change these numbers. And we're going to change that to -2, 0, 1, and 3. All right, so I want you to go ahead and try. So again, the steps are make sure it says y equals or the function notation equals. You're going to create yourself a table, and then you're going to graph those values. So go ahead and give it a try. So let's work through this and see what you got. So when you rearrange this, we should have had plus 2x on both sides, which would have gotten me y equals 2x plus 3. Now that I have each of those in, I need to plug in all of these domain values. So my x value and my y value. My x value, they told me -3, -1, 0, 1, and 3. I'm going to take each of these values and plug them in. -3 times 2 is -6. -6 plus 3 is -3. -1 times 2 is -2. -2 plus 3 is 1. 0 plugged in would be a +3. 1 times 2 is 2, plus 3 is 5. And then 3 times 2 is 6. 6 plus 3 is 9. So the range of each of these is -3, 1, 3, 5, and 9. So again, each of these would be points onto a graph. Notice the largest y value, I need to go 10 or 9 up, and I need to go 3 down, and I'm going 3 left and 3 right. So when I make this graph, I want to make sure that I have at least 9 squares. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines there. So I'm going to actually bring one further down. So we're actually using the graph paper to our advantage. So -3, -3, 1, 2, 3, 1, 2, 3, plot your point. -1, +1, 0, 3, 1, 5, and 3, 9. And again, I'm not connecting them because I was given 5 specific points. All right, let's check this other one for us. All right, so I am already rearranged. So I'm going to make my table, x on one side, y on the other. -2, 0, 1, and 3. So I'm going to plug these in. Notice this says squared, so it's the same number times itself. So -2 times -2 is 4. 4 plus 2 makes 6. 0 times 0 is 0. 0 plus 2 is 2. 1 times 1 is 1. 1 plus 2 is 3. 3 times 3 is 9. 9 plus 2 is 11. Notice I have all positives on this one. So I'm going to make sure I'm mostly positive for my y's. And for my x's, I need to make sure there's a positive and a negative because I am dealing with that -2. So plot -2, 1, 2, 1, 2, 3, 4, 5, 6, 0, 2, 1, 3, and 3, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now this looks kind of strange, but you're going to learn here when we have continuous that the squared is going to make a special shape. So in this next part, still on graph paper, we're going to now take a look when I have continuous functions. So if the function is given, pick your own set of domain to see the pattern, choosing numbers that are on your x-axis. Your graph is going to be continuous with arrowheads. So again, if only the function's given and they say graph this, and you're like, You're picking your own values. You're picking that x, and then you're plugging it in to see what y is creating. So the function is the rule. You just get to pick whatever values you want. So in this example, we have 2x plus 1 equals y. I already have y by itself. Take a look. He's hanging out there. All right, so do I need to rearrange this? So because I don't need to rearrange, I can get started. And you're like, well, what am I supposed to do? You pick your own values. Now, if I made a graph, and I can use this graph that I already had, it is all of the x values that I'm choosing. I can choose 1, choose 2, choose 3, choose 4. I don't want to choose 28. I don't have 28 squares to go to the right. I don't want to choose negative 10. I don't have 10 squares to go to the left. I want to make sure I choose numbers that are in this central location so it's easy enough to graph. Traditionally, we choose negative 2, negative 1, 0, 1, and 2 because it's in the pocket in the center. If you want to choose different numbers to see how it looks, that is entirely your prerogative, but I would encourage you to make sure you're paying attention to that detail. All right, so the purpose of this, I'm going to go ahead and I'm going to start my table. And again, I get to pick the values. So I'm going to pick 0, 1, and 2 because they're the 3 easiest numbers to calculate. And then I remember some of the things might be on the negative side. So I'm going to pick negative 1 and I'm going to pick negative 2. Now, certainly you can go from least to greatest, negative 2, negative 1, 0, 1, 2. But I just want to show you, there's no rhyme or reason. Pick what numbers you can easily compute. All right, now we're plugging them in. 2 times 0 is 0. 0 plus 1 is 1. 1 times 2 is 2. 2 plus 1 is 3. 2 times 2 is 4. 4 plus 1 is 5. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. And negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. So now that I know these details, I can go ahead and do it. So I have some positive and negative, so I'm going to make myself my plus. I have 0, 1. I have 1, 3. I have 2, 5. 1, 2, 3, 4, 5. Negative 1, negative 1. And negative 2, negative 3. And because I got to pick my own values, here's where I now connect the lines. Because technically, I could have chose a half. Half of 2 is 1, 1 plus 1 is 2. So at half, notice it crosses at 2. I could have chosen 2 1/3. I could have picked 4 1/8. So that's why there's numbers in between. Therefore, we connect, and then we put the arrowhead on either side. Now, if I only picked positive numbers, please make sure you're still extending your line to cover the other side of it. All right, so we're going to go ahead and try this one. I'm going to actually have you try this one. So I'm curious, what will your graph look like? All right, so I'm going to go ahead and pick my values, so x and y. Okay, so you guys can see it a little bit easier. And I'm going to pick my normal. You could have picked whatever values you wanted. I like to stick with that center core. Negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 0. 1 times 1 is 1. 2 times 2 is 4. Now notice, we have some commonality. So when you graph this, negative 2, 1, 2, 3, 4. Negative 1, 1, 0, 0, 1, 1, 2, 4. And I connect these. Notice I made a U. Now you might look at that and go, that's totally a V. There's a little slight curve to it at the bottom there. We don't just connect because it has to be a fluid. It's not jerking, and then moving there. All right, so make sure that you are connecting them appropriately. So what we need to learn is at the bottom here, absolute value, if there's bars around it, and squaring is always going to result in a symmetrical design, right? So absolute value, if the vertical bars are there, you're going to get a V. And if you're squaring, you're going to get a U. So just a kind of side thought for you as you do this. All right, we have one last area to look at, And that's if a graph is already given to me. So I have here finding values using a graph. The graph that's shown is f of x is 1/3 x plus 2. And I want to know what is the value of f of x. What is y? So we got to remember f of x means y. Those mean the same thing. When x is 6. So with this type of graph, you're analyzing it. So if you need more time, please pause so you can draw this out. Doesn't have to be perfect. But to solve this, I want to know when x is 6. So I go over, well, x is 1, x is 2, x is 3, x is 4, x is 5, x is 6, right here. So I go up until I hit the line. Once I hit the line, I bring it on over, and I realize that when x equals 6, f of x is 1, 2, 3, 4. So we're reading graphs and we're able to interpret them accordingly. So hopefully this kind of helped you out with understanding how to graph functions. Hopefully it reminded you how to graph in general, graphing points, and the difference between getting a domain and not getting a domain and how you would handle